When you dip your head beneath the crystal clear waters of the tropical ocean, one of the most magnificent sights you can witness is undoubtedly a coral reef. These marvelous ecosystems, with their unique beauty, teem with life. Colorful fish, swaying algae, mysterious sponges, graceful turtles, and thousands of other creatures coexist with the corals in perfect harmony. In recent years, coral reefs have frequently made headlines as poignant symbols of the challenges posed by climate change and biodiversity loss. Indeed, these underwater jewels are experiencing an alarming global decline due to rising water temperatures and ocean acidification, which directly affect their main constituents. Given their crucial role in maintaining marine ecosystem balance, corals are at the center of numerous research efforts worldwide. These studies aim to enhance their resilience and prevent bleaching to preserve these sea treasures for future generations. Yet corals still hold many secrets and could even prove useful for predicting volcanic eruptions.
My name is Tom Schaudrich, and I'm an assistant professor at the University of Geneva, and I have an ongoing project funded by the Swiss National Science Foundation to look at the interaction between volcanic eruptions and corals.
Tom and his team from the University of Geneva have embarked on a quest to uncover the mysteries of the physiological response of corals to volcanic eruptions. Their ultimate goal is to determine whether coral skeletons can become the silent keepers of these volcanic events, thereby serving as natural archives of past upheavals. To achieve this, they are examining the chemical composition of coral skeletons collected directly from the ocean, seeking to detect subtle variations that reveal environmental changes through the ages.
So here we are working on the island of St. Vincent. We're working here because there was a recent eruption in 2021. And so by having a recent eruption here, we can understand the effect of this recent eruption on the chemistry and the microstructure that we then measure when we're back in Geneva.
My project is investigating how this eruption is imprinted on corals and coral reefs to understand the interaction specifically between the ash produced from this eruption on the coral reefs around volcanic islands. And also we investigated, for example, a non-volcanic island, which is Barbados, which is around 180, 190 kilometers east of St. Vincent, where we are now. And we're investigating the effects of sort of distal and proximal effects of the ash on the two islands. So that's really what the project is about. It's trying to find the imprint of a volcanic eruption on the coral reefs and specifically on massive sclerotinian corals. But I guess the plan is to snorkel, get an idea of what we're seeing.
Yeah.
And hopefully we'll find something. And if we don't have time to drill today, we'll do it tomorrow.
Exactly.
To successfully conduct their explorations, the scientists must have a deep understanding of the seabed surrounding the island. Technical dives are not something that can be improvised. They must be carried out with great precision and efficiency because they are expensive in terms of equipment, time, and energy. Every detail must be carefully planned and orchestrated. Fortunately, Tom and his team can rely on the support of local experts like Nadia Huggins and Stefan Hornsey, photographers involved in various marine biodiversity protection initiatives, as well as Tobias Herberg, a professional diver who guides and accompanies the team into these mysterious depths.
Good. So our plan, I think, is should we just go north? Should we ask Toby to take us
To the reefs he knows.
to the reefs he knows?
And not, let's just say, if he knows anyone close to the Walaboo River, that's the main objective here, is the Walaboo.
Yeah.
So if he knows anywhere close, it's better to go north of the Walaboo, I think, if we're looking for reefs up there, or just below it. Yes. Look at that coloured door.
Yeah.
Breathing.
Yeah.
Just recommendations at the start.
Yeah.
Just to see we're following you.
Because you know everything. When we go into the ocean, what we do is we dive. We take coral cores with the underwater electric drill, and they can range in depth from 10 centimeters to 30 centimeters. And this allows us to reconstruct maybe 15 to 50 years of growth of the coral. And so when we take this core out, we can then measure this core and understand the variation in its environment over the past 50 years.
And the main goal is to try and find a specific signal within the coral, whether that be geochemistry, any growth differences, or even, for example, physical incorporation of ash. The main goal is that we can find these signatures and be able to reconstruct them in fossil corals in order to use corals as a way of reconstructing past volcanism through time in the geological record.
The sampling of corals along the coasts of St. Vincent is carefully regulated to preserve the island's rich yet fragile biodiversity. The scientists, under the benevolent guidance of the local authority represented by the Fisheries Division, have been granted permission to pursue their quest for knowledge. However, they must adhere to strict guidelines. Through a meticulous selection process based on the shape, size, and location of the corals, the researchers ensure that the harmony of the sea is not disturbed. Once the sample is taken, they gently close the hole left by the drill, thus preventing the intrusion of parasites or curious fish and protecting the delicate marine structures from any alteration. This collaboration with the Fisheries Division proves to be a harmonious dance, where the valuable data collected by Tom and his team become shared treasures for the monitoring and preservation of the reefs of St. Vincent.
So my name is Shamal Connell. I work at the Fisheries Division, St. Vincent and Grenadines. I work there as a fisheries officer. I'm responsible for biology and research. It's always useful to have other persons come in and conduct the research and collect the data, because then that data is also useful to us. Especially when you look at the fact that we have limited resources ourselves to conduct a lot of this research.
When we take the coral cores out of the ocean, the top of the core still has the tissue on, so the first thing we do is we bleach the tissue to get rid of the tissue at the surface. And then once that is done, we dry the coral cores and then we ship them back to Switzerland. For this, we work with the CITES export and import procedure, as corals are a protected species. Once they're back in the lab, we will then firstly use the microcomputer tomography on the whole core. And so the idea here is to then reconstruct the whole circular core, which we can then use to reconstruct the variations in density or porosity throughout the whole skeleton. That's the first step we take, because that's a non-destructive method. After that, we then cut the sample in half, so we have a smooth, flat surface. And then we can use this flat surface to analyze using laser ablation. So this is a method where we take this sample, we put it in a chamber that has a laser in, and the laser ablates the sample. So we get a little bit of sample, and this is taken into a machine that measures essentially the chemistry of this sample. And we can do this on little spots all the way down the skeleton to reconstruct the chemistry.
The few centimeters of coral extracted by the underwater drill are invaluable, offering a treasure trove of essential information to unravel the mysteries of how volcanic eruptions impact coral growth. When the La Soufrière volcano in St. Vincent erupts, thousands of tons of ash soar into the atmosphere, falling as fine dust over land and sea. At the bottom of the ocean, a grey layer forms, enveloping the reef in a shroud of ash. The rain then washes the terrestrial ash into the ocean, where it is sometimes absorbed by the coral skeletons. In 2021, a massive and devastating eruption deeply affected the island, its inhabitants, and the surrounding ecosystems, leaving indelible scars in the hearts and memories of the residents.
I was sleeping. I heard this low song, like a plane is like going through the clouds. I get up off my bed. You know, my father called me and telling me that Soufrière Bleu. That's what we say, Soufrière Bleu. So now where I live, right? I live on a hill, like, and I can run up on the hill to go up on the road to see Soufrière. So before I packed, I wanted to see because I was here, I want to experience it as well. You know, I was frightened, plus excited, and mixed emotions. I came up on the hill looking forward to see lava spewing and all this thing. Nothing like that. The only thing I see is a cloud of darkness. When I was home now, I stayed at home my day. People calling me why I'm not moving. I said, man, nothing not gonna happen much. Then later in the evening, he heard another explosion. Oh my God. When we saw that explosion, it was like cloud and cloud just climbing. It was just climbing, climbing, climbing. Then when I saw that, I told my dad, let's go up, let's move out of this place. So now he erupted on a Friday, then the Sunday we came down. When I came down, the place was like a wasteland. It was like an atomic bomb drop, and everything went like, it was like, when you look at this, you wonder to yourself, if we're gonna move back down here, are we gonna go back home? Is it gonna be livable? When we gonna clean all of this ash and all this thing?
The eruption caused the evacuation of around 20,000 people. There was ashfall that blanketed the whole country, and it caused water restrictions because of the sedimentation of the ash. The heavy ashfall also affected a lot of infrastructure. The roofs of people's houses collapsed. The ashfall also limited air travel in St. Vincent and Barbados because the airports had to close because of the heavy ashfall.
All of that, so we took our time, we cleaned our yards. Then after, people come down, help people. Some people paid to their roof to be cleaned. And all of some people come, we started to shovel the ash. Every time we come down, we bit by bit. But all in one, right? It was a good experience that I can end up and tell maybe my children, other people when I travel out, but it's an experience that I don't want again.
Currently, studies on the frequency and intensity of volcanic eruptions in tropical island environments are relatively rare. By analyzing the composition of corals collected after the 2021 eruption, Tom and his team will be able to examine how the volcanic ash has affected their internal structure. This analysis will help determine how to identify the traces left by eruptions in the coral skeletons, whether they are recent or thousands of years old. By doing so, they will be able to trace past eruptions and gain a better understanding of the activity cycles of certain volcanic systems that are still understudied.
You can see in the geological record many volcanic eruptions. The timing of eruptions, say over the past few millennia, is not very well constrained past a few hundred years. So I think the focus would be using coral cores that can go back, say, a few millennia to understand the frequency of volcanic eruptions and also how long they last. So one of the key factors in a volcanic eruption is you will want to evacuate the population when there's an eruption, but then when do you bring the population back? When is the volcano safe again? Will it erupt again? How long will it take to erupt? So these are all questions for the local population who live around the volcanoes. And it's something very, very hard to constrain because volcanoes can erupt maybe once every 30 years, or maybe even longer, once every couple of 100 years. So understanding how long an eruption will last at a particular volcano is often quite difficult. An eruption can last, let's say, just a few months, as was the case here in 2021 in St. Vincent. Or in Montserrat to the north, the eruption commenced in 1995, and then the last eruptive activity was in 2010. So eruption can last for very, very different time durations, and this very much influences how the local authorities have to manage the hazard associated with the volcanic eruption. So for me, the utility of corals is to identify these smaller events that are maybe not in the geological records, and also try to characterize how long they last for, because that's impossible to do using the geological records.
By applying chemical dating methods to coral skeletons and considering their growth rates along with the volcanic eruption traces present in their structure, researchers will be able to precisely determine the timing and duration of past eruptions. This research will not only help predict future eruptions, but also enable the implementation of appropriate protective measures and the communication of results to the public.
NEMO, the National Emergency Management Organization responsible for coordinating any natural disaster in St. Vincent and the Grenadines. There are some challenges that come with public awareness as a whole, but the people of St. Vincent and the Grenadines, they are always willing to learn, and so it's easy for us to just go out and educate them on anything. They ask any questions, we answer. And I mean, that is the whole purpose of us going out and just sensitizing the public. So it's just to make them feel comfortable with the hazards that we experience on island, and for them to be able to be aware and know how to respond if any of these hazards actually do hit them. So they won't be unaware of anything that happens.
Although much of the researchers' work in St. Vincent is done underwater with an oxygen tank on their back, scientists also need to work on land to better understand how ash has covered the corals they collect. To achieve this, and with the help of NEMO volcanologists, they explore the narrow valleys that, during heavy rains, transform into powerful mudflows called lahars, carrying everything in their path down to the sea.
Right now we are at the Valibu River. It's approximately 3.5 kilometers from the summit crater of the La Sofia. And in 2021, this La Sofia volcano erupted quite violently, and it left behind 20 or 30 centimeters of tephra, of ash, lapilli, and pyroclastics. What you can see here in the riverbed, you can see like perfect cake shapes of certain pyroclastic deposits, but not only from the eruption from 2021, but also from other eruptions from 1979, from the beginning of the 1900s. What you can see here, this was the area or the phenomenon where many lahars, so ash, water mixtures, pressuring into the ocean and affecting the coral reefs which are right over there. Right now we can only see a small river going through this Valibu River, and most of the river is dried out. But based on the mass amount and the structures of the ash deposits here, we can see that the lahars had a big influence of the geomorphology of this area here. Even if you look in the background, you can see many dead trees, because if you have also lahars which can swirl down the volcano with up to hundreds of kilometers per hour, you can see that those hot debris currents can even light up the trees and kill the trees in the vicinity. Wow. Wow, wow, wow. All got pulled away, pulled with the lahar. See, like an agglomeration of tree trunks, all completely freed of the berg or birch. Just the bare wood, burned off and dragged along, and encapsulated and within the volcanic deposit. Wow. What kind of forces there happened. And lahars come down every once in a while. Every time when it rains, you have the potential of lahars just coming down the same pathway as 3 years ago, as 2 years ago. Pretty dangerous.
These narrow valleys, among the rare places where vegetation is sparse, provide ideal conditions for collecting volcanic materials such as ash, which will then be analysed in the laboratory by scientists. It was precisely in this laboratory that the scientists made an unexpected discovery.
So what I'm doing is I assess the effects of volcanic ash on corals in a laboratory setting. And with this, we should gain mechanistic understanding of how the coral interacts with the ash. And those knowledge we want to then trace back or transfer to the field, and those results we want to observe now here on St. Vincent. So I work in collaboration with the Centre Scientifique de Monaco. We have there aquaria, multiple aquarias. The big advantage of working in the setup in Monaco is that we can monitor all environmental parameters. We can control the temperature, the salinity, the pH, and we can monitor. So what we are doing is we monitor over the 6 weeks period. When I added in frequent amounts of ash into the tanks, and we monitor the fluorescence response, and we also measure, for example, the weight of the coral. So if the coral grows faster or slower, we can measure this. And if you look up in literature, most documented response of the coral reef to volcanic eruption is the smothering or the mass mortality of the reef. But what the people are not investigating, or which was investigated prior, was the effect of moderate ash exposure for much more distant coral reefs. Our findings from last year, from 2023, we published recently, and we showed how volcanic ash is beneficial for the coral. And the beneficial part of the volcanic ash is due to its leaching of micronutrients. So when you have ash and put it in seawater and any water, you have the release of many metals. So if we add a manganese iron solution to corals, we can see that the photosynthesis rate is increased. If we add ash in the tanks in Monaco and we look at the response, we can see that also the photosynthesis is increased. So all the effects which we documented is most likely due to the leaching of the micronutrients, which are contained and trapped in the ash, but released rapidly once in contact with the seawater. Because what we found out is that small amounts of ash can make the coral more resilient against external pressures like temperature increase. If you put desert dust on Stylophora pistillata, which is a tropical coral occurring in the Red Sea, you can see that those corals are much more heat resistant than the corals which are not experiencing the desert dust. And similar results we observed with the volcanic ash.
Scientists have discovered that, when present in moderate amounts in the ocean, volcanic ash can promote coral growth. These findings are crucial for a better understanding of coral biology and for developing more effective conservation strategies. This is particularly relevant in St. Vincent, where corals are experiencing severe decline due to water warming and other impacts related to human activities.
A significant portion of nature is covered by reefs. Unfortunately, these reefs are not in very good condition. Overfishing might be an issue, so unsustainable fishing practices might be a big problem. That might be one of the major risks or threats to look at. There's also sedimentation coming from the rivers, as well as nutrient pollution. Because all along the coast there are persons doing farming. You utilize fertilizers, and that might be creating a lot of nutrient loading into the nature. So those are potential threats and causes for what we're seeing currently.
Other factors, such as over-tourism, add to the long list of threats to marine biodiversity in St. Vincent. The Fisheries Division works tirelessly to mitigate these threats and regulate their impact. Meanwhile, some initiatives have established underwater coral farms. By selecting the most resilient specimens and harvesting small fragments, these projects propagate the corals on suitable structures, thus promoting their growth and conservation. Tom and his team have embarked on an extraordinary project that has led to unexpected discoveries, marking a significant turning point in the understanding and use of corals. The study of these organisms' skeletons will soon refine predictions of tropical volcanic eruptions, estimate their duration, and better protect populations from the dramatic consequences of catastrophic eruptions. Additionally, scientists have found that volcanic ash, when present in small quantities, can actually stimulate coral growth. This discovery offers promising new avenues for enhancing the preservation of these vital organisms within our global ecosystem.